Buenas tardes. This is my first talk in English. As Fakul mentioned, my Portuñol is awesome, but I will avoid you to hurt my Portuñol. Today, I'm going to talk about Kotlin standard library, and let's get started. But before started, I would like to say thank you to the organization of the event to having me here, and to all to be here. It's awesome to be here in Argentina. It's my first time, and yesterday I walked around to the city, and it's a beautiful city. Congratulations for you all. What do we cover here? The Kotlin standard library provides the essential classes and functions for your everyday with Kotlin. Okay? In version 1.3, it contains approximately 50 sub-packages organized in 4 categories. And today, I'm going to cover these 2 packages, the common, which it's common for every platform, and JVM for JVM platform-based, like Android or servers if you are using Java on server. The first topic that I will cover here is the scope functions. As the name says, the scope functions create a scope for your object using Kotlin. Okay, so it's the main reason to use scope functions. And I think another speakers talked about some of these functions. I will try to bring an easy way to understand how to use these functions and how these functions works. Okay. The first one is the let function. Okay. As you can see, it's an extension function, which means that I can call this function from any object because I'm using the T. So this T is a generic type, so you can call from any object. The caller is represented by it. It returns the last line of the block. It's important. And it's commonly used for nullability checking. I think other developers mentioned that. But it's very common to use the let function for nullability check. So let's take a look. Imagine that you have this sample here. I try to bring all samples from in the slides from my last projects, for example. So I have this function, delete temp photo, and this temp image file can be new. So I can't assign any file to this object. And when I use let, I can check if the file exists, and in this case, I delete the temp file. Okay? But you can ask me, Nelson, I can replace this code using this. It's more simpler. It's more readable. I checking if the temp image is different of new, and thanks to the SmartCast, I can check directly if the temp image file exists, and then delete the file. It works, no problem here. You can use this code. You don't have to use let just because it's beautiful. It does not make sense to use let in the sample. But let's expand this example a little bit. If the temp image file is part of the class, is an attribute of the class, is a property, when I try to, if I try to replace the old code using this, you get an error. You get an error. The SmartCast to file is impossible because temp image is a mutable property that could have not been changed. Imagine that in this case, here I have a variable, so it's not guaranteed that this image file is not new anymore. Because when I check if it's new and check here, this variable can be new, changing by another thread, for example. So you can replace the code for this approach, but this approach is like weird. Okay? It's weird. But it's not only weird, it's dangerous. Because what can happen here? The temp image file is different of null, and this test passes. But now another thread changed the temp image file. So imagine that at the beginning, I have the file 1 assigned to temp image file. The check is different of null? Yes. So another thread changed the temp image file to temp image file 2, so file 2. And in this case, it will delete the file 2 instead of the file 1. So this is weird, ugly, and also dangerous. So in this case, the let function is better because it covers all the scenarios that we can have with this nullability thing. Okay? And I mentioned before that you can access the object using it inside of the block. But of course, you can rename the variable using, in the sample, I use file. Okay? It works. The second function is apply, which is also an extension function. The color is represented by this. I didn't mention in the first function, but the color here is the object which is calling the function. So I'm naming as color. So the color is represented by this inside of the lambda. And it returns the color itself. It returns the object itself. And it's commonly used for initializing and configuring an object. Okay? So imagine this sample here. Chip is just a UI component for Android. But as you can see here, I have a lot of properties that I'm setting to the chip. Okay? So I have this replication here. Chip dot, chip dot, chip dot. So you can replace this code using apply. So inside of the apply block, because of this, the name is scope functions, because I create a scope for that object. So inside of this block is the object itself. So I'm configuring the object inside of this block. Okay? So after configuring my object, I'm adding to the chip group. Okay? So apply for initialization. The next function is also, which is also an extension function. The color is represented by it. Inside of the lambda, we represent the object by it, or any name that you want. It returns the color itself, and it's commonly used for initialization chaining, or do something else with the object that you are using. Okay? So let's go back to the previous example. We have the chip variable here, and this variable is just used to add to the chip group. Okay? So this chip variable only exists to add to the chip group. And we can replace this code by this code. So we are creating the object, configuring the object, and also adding this object to the chip group. Okay? So you can ask me, Nelson, can I add this chip group add view inside of the apply block? Yes, you can. But in this case, this is the reason, again, this is the reason we create scope functions. In the first scope, we are initializing the object. And in the other scope, we are adding the object to the chip group. Okay? So this is the reason. This is the reason that Florina made the talk about idiomatic Kotlin. Here, we are making our code more idiomatic. We are creating and also adding the object to the chip group. Okay? The next function is run, which is an extension function. The color is represented by this. It returns the last line of the block, and it's commonly used to run an operation over an object and get a result. This is the most common use. But the standard library also has a different function, which is a simple run function, which is not an extension function. There's no reference to the color, because it's not an extension function, so I can call this function anywhere. It returns the last line of the block, and it's commonly used to get a result over an operation. So you are creating a scope to run a series of statements, and after that you want to get a result. You can use the run function. Okay? This is an example from Android code. And here I'm using the preference manager to get the default, the favorite city from the preference, from the preferences of the user. And here I'm getting this preference and using the Elvis operator to get the default city if the preference is not set. Okay? And okay, this code works, but we can do this code more easily. As you can see, I'm just declaring this prefs variable just to access the preference manager. Okay? So we can replace this code using this. We get the preference manager and run an operation over the preference manager. Okay? So once I get this result, I'm checking if the result is different of null using the Elvis operator here. And if it's null, I get the preference from the string resources. And you can ask me, Nelson, I can use the getString directly here. Yes, you can. It's just simple to demonstrate the two run functions. But imagine if you have more lines here, this code will be more readable because you are creating a scope for preference manager and also another scope for when you don't have a preference set. Okay? And the last function is with. With, it's not an extension function. The color is passed as parameter, so the name color, the color here is not good because it's not actually calling anything, but the object is passing as parameter, and it returns the last line of the block, and it's commonly used when you want to remember Delphi. Is there any Delphi programmers here? Oh yeah, two Delphi programmers, yeah. It was the first time that I saw this instruction with. And particularly, I don't use this function. And I was rehearsing this presentation with a friend, and he said, why you simply just remove these slides? No, I would like to explain why I don't use with function. For example, here, I have this web view, and using with, passing the web view, and I can call this instructions here directly over the web view. Okay, it works, no problem here. This code works perfectly. But imagine that the web view is new, can be new. This code will not work because you have to access the web view using the save operator, the question mark dot. Of course, you can replace this code using this. But why are you going to use this code instead of this code? I can just use let, or I can use apply, let, also anything else, but not with. Okay? So I will stay here after my call, of course. So if you have a good example of use of with function, please tell me that, because I don't have one. I don't use with. Okay? Well, just a quick summary here. Use let for nullability check, apply for initialization, also for initialization chaining, or simply to change the scope of the object, run to get a result from an object or sequence of calls, and with, for some reason, I don't know how to explain. Okay? So, my next topic is annotations. I really like annotations because it helps to the evolution of your code. Okay? So, in this topic, I will cover one thing that's important for developers. In this case, you are writing an API, for example, or if you are creating a code which is integrating with Java code, and just a beginning of if you like to use DSLs, domain-specific languages. It will have a talk about DSLs that I really encourage you to watch after my talk, I guess. It will be very interesting. Annotations. Let's say that you have this function, say hello, and now you decide to create a new function called greetings, which do the same work of the hello, say hello function, but now it receives a parameter, which is optional, the message. A good practice is, I just put this simple function here, but imagine that you are writing an API and you have a big function which does some work, and now you are creating a new one. A good thing to do is add this deprecated message in the old function. In the deprecated function, you are saying this function is being replaced. This is the message. The replace with is the tip that you are giving to the compiler and the IDE to what function this function is being replaced. Okay? In this case, greetings. Okay? And the level of deprecation. If you are sure that, or you are sure that this new function is replacing the old one, you can use the deprecation error to avoid the developers to use the old function. But when you are migrating, you can put a warning. If the user tried to use the say hello function, it will receive this message. Replace with greetings. And if you click here in IntelliJ, it will replace your old function for your new function. Okay? So when you are using the Android and you see a deprecated function, this is how the things are made. Okay? But we have a different scenario when you just create the function, but you are not sure that this function will replace the old one. Okay? So I have this logging function, which receives username and password. Now I create this auto user, and now I define this new function, logging, which receives the auto user, my new class. Okay? A good thing to do is put this annotation here, declare this annotation as new API or the name that you want, and mark this as warning or error if you prefer, and set the auto user and the logging function as new API. Okay? In this case, you are saying that, look, I'm writing this new function, which is experimental, but everybody knows that today's experimental code will be your production code tomorrow, right? So, yeah. If you want to use this experimental code, you have to use this use experimental and mark your new API annotation class. Okay? So there are two cases here: the deprecation that you are sure, and the experimental when you want to add new functions. Okay? I'm talking about the APIs, but it's very common in Android, particularly when you write some modules in your app. And you have a big team in Android applications, for example. In my last project, we have, it's not a big team, but we have 10 developers, okay? So it's complicated to have all the developers in the same page, in the same, working in the same area of the app. So it's important to document your code, okay? Another topic is related to integration with your Kotlin code with Java code, okay? So let's talk about these annotations. Imagine that you are defining this user repository object, which is not available in Java, okay? And you want to access this code in Java. So you get this user repository .instance .insert user. This is kind of weird, instance. You can avoid that declaring your function as JVM static. And in your Java code, you can just remove the instance. I watched the presentation regarding the Kotlin bytecode in the morning, and this will avoid you to create more functions because you don't need that instance object here. So using this JVM static, you avoid to create that instance object, okay? The second case here is, imagine that you have this class, my Kotlin class with print name, but notice that this function has optional parameters. If you try to access this function from your Java code, this call will work, but this one will get an error because the compiler just creates the function with the string, but the string is optional here. What I can do to fix that? You can add the JVM overloads. In this case, the compiler will create one function with parameters and another without parameters. So now you can call your function normally. Guys, I mentioned that because nowadays a lot of developers are writing code in Kotlin, but there's a lot of projects which were written in Java and now is migrating by steps to Kotlin. So it's very important to have a Kotlin code working with Java, okay? And in Android particularly, it's very common to write custom views. And if you write a custom view in Java, you have to override these 3 constructors. The first constructor with context, the second with context and attribute set, and the third one with context, attribute set, and style. If you click on the IDE, convert to Kotlin, you get this code here, the 3 constructors. But even though it's annoying to have these 3 constructors, you can simply add JVM overloads and you just get 1 constructor, because the JVM will generate the 3 constructors for us. Okay, this is very good. Let's say that you are creating this toggle view component, and you write this switch, this simple function switch, which change from on to off, switch between on and off. Okay, but if you try to call this code in Java, as you know, this code, switch, is a reserved word in Java. So you can't use switch. In this case, you can use the JVM name to rename the function which is generated by the compiler to this function. And in this case, you can call switch on off in Java code. Okay? Imagine that you have another cases that in Java, in Kotlin is not a reserved word, and in Kotlin, in Java is. Okay, so it's important. It's also work for class name. For example, imagine that you have data, for example. Data is a reserved word in Kotlin, but it's not in Java, for example. Another feature in Kotlin that I think most of the speakers talked about here was extension functions, and it's awesome. But imagine that you have to call these extension functions from your Java code. It's possible here. You just can call this string extensions KT. It's weird because the file name is string extensions.kt, but we don't have any class here. This is the default class name which is generated by the compiler. You can also rename this class using JVM name. So instead of have string extensions KT, you can just have string axt, for example. Okay? And it's shorter and more Java friendly per se. Okay, let's imagine that you have this product class which just have 3 properties. And that's okay. You can access this code using Java, using getID, getDescription, getPrice. But the Android developers know that the number of methods that you have in your application is important. We have a limit for this. Otherwise, you create more APKs, more parts of your APK, more DEX files. And you can help to avoid this just adding the JVM field. Using JVM field, you can access the field directly. But behind the scenes, it's generated a public final field in Java. So you are avoiding to create 3 methods here. Okay, 3 methods here. Imagine the number of data classes that you have in your application. So imagine all the properties that you have. Imagine the number of methods that you are creating unnecessarily. Okay. Okay, I think less regarding this topic, but no, it's not. If I create this constant here, it will generate this code here, my Kotlin class.companion.getConstant1. But it's a constant. I don't need a method for that. So the constant two using const vol, you generate my Kotlin class dot constant two. So again, you are avoiding to create methods unnecessarily. And JVM field, you do the same for the constant tree. So here is the same case. For the third case, for the last case, the const val is just for primitive types, just for integer, in strings, double, boolean, but doesn't work for objects. So in this case, you have to use JVM field to get this constant here. Okay? So look at these annotations. They are important to avoid the number of methods. Another important thing is this method here is throwing an exception. But so you can call this function directly from Java, because all the exceptions in Kotlin are not checked exceptions, are runtime exceptions. But you can force your Java code to treat these exceptions using the throws annotation. So with the throws annotation, your Java code must have to wrap this code using try catch. Okay? And the last topic about annotations, I was thinking if I should add this example or not. And I decided to bring this sample because I thought very interesting. It's not my sample. I bring from another talk from a guy that I don't remember, but I promise that I put the reference here. Anton, he's from Poland, I guess. But I saw this example in a Kotlin Conf presentation. But imagine that you declare these two classes here, and I would like to create my DSL, okay? My DSL, domain-specific language. And, okay, I have a recipe with a list of ingredients, and each ingredient have a description, quantity, and unit. So I create two functions to declare my DSL. The recipe, which receives a recipe dot. This syntax is weird, right? But remember one of my first slides? Apply. Look at the syntax here. The name of this syntax is extension lambda. Searching for this after my talk. This is very powerful because you are adding here an extension function, which is a lambda to your call. And here I'm creating a recipe calling apply, and inside of apply, everything is recipe. So this lambda inside of apply is a recipe. And the same thing or similar thing, I'm doing this for ingredient. I'm creating ingredient, calling apply, calling the build function, which I passed as parameter, and I'm adding the ingredient to the ingredients list. Note, but Nelson, where does ingredient come from? This is an extension function of recipe. Recipe has a list of ingredients, so I can call directly. This is crazy, right? But it's very interesting. I'm very excited about this stuff. Yeah, I'm very happy with these things. But yeah, so you can call the recipe function and set the name of the recipe, because again, inside of this block, I have a recipe. And once I have a recipe, I can call the ingredient function, which is this function here, okay? Recipe, ingredient, and I can set the name, the quantity, and the unit of the ingredient. Nice. If I call print line, I will get this. Why floor? And description is new. Oh, I see. It's because name, it's actually the name of the recipe, and I'm setting floor. How can I fix that? Well, one thing to fix that is create a DSL marker. It creates a scope for your DSLs and avoid to access other scopes. You can just access your scope, the scope of your class. So I define the two classes here as recipe lang, which is the name of my annotation. And now, if I try to run the same code, I'll get this error because I'm trying to access the name property, which is not the ingredient property, it's the recipe property. Of course, you can access the name property this way, and the code will work, but actually what we want here is the description field. And now, the chocolate cake has your first ingredient. Of course, you can add more ingredients, but I can see my cake is in progress, okay? This is a very interesting example. Oh, by the way, I will share these slides with you after the talk. I'll post in my slide share, okay? Okay, so the summary for annotations. Use deprecated and experimental to help to document your code. The JVM annotations to help the integration of your Kotlin code with the Java code and vice versa. And DSL marker to create scopes for your DSL. Okay? Okay, my last topic, I promise. Delegates. Delegates is a very interesting topic, which I didn't study very much, but now I can see how powerful it is. Okay? Delegates. Let's say that you have this individual class, and you have the student class and worker class, which extends individual class. Okay? Not wrong here. The only problem here is that we are repeating this name, surname, and age 3 times. We can improve that using delegates. How can I do that? We can create this individual interface and abstract the individual data. And now I'm implementing individual. And inside of student and worker, I'm using individual data as parameter. This is interesting because here I'm using 2 concepts of computer science. I'm using extension and composition because here worker is still an individual, but I'm using the composition to avoid the replication using individual data. So I can access here directly student, individual data, the university name, and I can call directly the properties name, surname, age, and diversity. And why it's called delegates? Because when I call, for example, student.name, the name property which is being called is the individual data. Notice here, individual by data. So all calls that I'm doing for the individual properties, I'm doing through the data property. Okay? This is very cool. So this is the output. The other delegate, which is very common used in your daily basis with Kotlin, is the lazy, which is basically if you are new, initialize this object. It's simple like that. Okay. So in this sample here, if you instantiate the repository, at the first time, the people DAO is new. When you call insert, it will check, oh, people DAO is new. Yes, it's new. So instantiate it. When I call insert again, the people DAO is already instantiated and I call directly. Okay? It's very simple. It's just a lazy initialization. Vetable, it's another delegate, and it's very useful when you want to separate a logic for assignment in a given type. It's complicated, right? Let's see a good example here. This delegate is checking the age of a person, and I put here if the new value is in between 0 and 122, which is the oldest person in the world in accordance with Guinness Book, Jane Coleman. And you wrap this logic in an age delegate, and you should do that using a function, because if you don't, every time when you instantiate a property again, you get the old value. So you have to do this declaring a function which uses a delegate. And now, in your class, you can declare a property like age by age delegate. Imagine that you have, for example, a class person, and now you have another class called worker, like the previous example, but it's not an extension. And yeah, you can abstract this logic using a delegate. And if you try to set -1 to the age, or 150, you get the 0. This value will not be assigned. So you are encapsulating the logic of the validation of your property in a delegation. Okay? This example I bring from my last project. It was used, for example, I was working in an application to search houses. And you can search houses by the number of baths, value, the space, and a lot of parameters, the region, the city, and so on. So imagine that this filter class has a lot of properties. And this object, this filter object, is shared across several UI components. And every time when I change one filter property, I must have to update my UI component, and in some cases update the UI for some reason. Okay, so I just put 2 properties here, but imagine that you have 20. And here I have some callbacks, which I'm adding to notify changes. So each UI component has an instance of, have the same instance of filter, but the UI component is registering as callback, okay, of the filter. So that's the idea. So I create this notify users, notify observers function. And now to solve the problem with the callbacks, the UI callbacks, I use this. I create a filter delegate, and as you can see here, the reference of the property is a filter. And every time when I set a value to that property, I set the value internally and call notify observers. And now my filter class is like this, min bat num by filter delegate. Okay? So if I instantiate a filter and add 2 observers here, 2 callbacks, and set the number of baths, min price, min bath num again, and min price, I'll get this. Look, I set 2, and the 2 observers are called. I set the min price, the 2 observers are called. And the same here for the last 2 properties. Okay? So I'm abstracting the logic over my properties using the delegates. Okay? There's a shorter version of this delegate, which is using observable. Observable is useful when you want to get the old property and the new property. Okay. So in this case, I have the old value and the new value. Okay. And again, I'm calling the observers. Okay. And notice it's an extension function. If you are new in Kotlin, you know you have to learn extension function because it's used every time, everywhere. Okay? So here, I'm declaring my min bath num and min price using by filter delegate. Okay? And I'll get almost the same result. If I add the observers here, I can get this result. Min bath num, before was 0, now is 2. The min price was 0, now is 100,000, and so on for the other fields. Okay? So, the summary for delegates. Interface delegation for composition, that example using individual data, person, and so on. Lazy for lazy initialization. Vetable to define a validation to be reused. Observable if you need both old and new values. And custom delegates for everything else. Okay? Okay, my last slide, I guess. Standard library has a lot of functions to help you to write more simple and reusable code. Okay, so I can't cover everything about standard library here, but check it out, the internal lib, the library internals. You learn a lot. If you look at the internals of apply let function, you see, for example, contracts, which is a content that I didn't add to this presentation, but it's very interesting how the contracts works, and a lot of other things. And if you are new in Kotlin, check it out, the Kotlin colons. It's a good point to start, and there's a lot of samples and exercises to use Kotlin standard library. And write Kotlin code, enjoy the standard library, and have fun. Here I have some reference. The slides will be available today, I guess. And that's it. Gracias. My name is... Thank you. I think we have space for questions. Okay. Okay. No.
It's the other side.
Okay.
The other side. Yes. Yes.
Hello?
Ahí te lo traigo de vuelta.
Hello. Hello. Okay. Okay.
Well, my question is about the annotation JVM name.
Okay.
Does the IDE search the usages of that new name for Java, and how does it behave?
Yeah, it will search for the new name. This is awesome because, yeah, and also dangerous because if you rename the string there, you have to change everywhere that you are using because it's generated at compile time. So if you are using the new name in your Java file and you rename just that string, you have to rename everywhere. At least as far as I know. I don't know if the JetBrains do some magic to, yeah. Yeah, thank you.
¿Hay más?
More questions, please.
Vamos.
More questions? Okay, I have one.
Va.
Do you have a good experience to integrate Kotlin with the Spring Boot on backend service?
No, I'm sorry. I'm an Android developer, so I just have the experience, but with Kotlin, with Android. But I think that people are using Ktor for Kotlin. I'm not sure if the Spring Boot you said, right? Yeah, I just heard about the Ktor for Kotlin. Yeah, I'm sorry for that.
Okay.
Good.
¿Hay más?
More questions?
A la una, a las dos, a las tres. Un fuerte aplauso para Nelson, por favor.
Thank you very much. Muchas gracias.